Welcome you all. I, Dr. Archana Sharma, Associate Professor, MC Department, IIMT College of Engineering, Greater Noida. Today, I will discuss about cryptography. So, before I discuss about the cryptography in detail, the topics which would be covered in this particular session, let's discuss all these. That is security objectives, cryptography concepts, types of encryption operations, types of cryptography, and applications of cryptography. So, what are the basically objective of security? Why we are looking for the security perspective? Here we have the three perspective of the security, that is confidentiality, integrity, and availability. So, when we are looking towards the confidentiality, what exactly the meaning of it? Suppose the sender and receiver are communicating over the network, and some third person who is unauthorized to go through with the contents of your contents between the sender and receiver, looking for all these contents. In that case, that is the breach of security. Suppose I am withdrawing the amount from the bank, that is 50,000, and the third person who has just steal your IP address and trying to update that contents from the 50,000 to 5 lakhs, that may be the part just modifying the contents over the network. So that is the breach of integrity. So prevent, detect improper modification of information is considered as integrity. And the third one is the availability. Suppose ki you are trying to access any service from the server, but server is unable to deliver that service. In that case, you will say the prevent or detect improper denial of access to services provided by the system. So here we have the three objectives of the security, that is confidentiality, integrity, and availability. So when we are saying these are the three key perspectives of the security, then definitely there must be some mechanism to maintain these confidentiality, integrity, and availability. So here when we are talking about this confidentiality, that is the secrecy, for that we will look for the concept, that is cryptography. So here I have tried to summarize the concept which we have discussed at present, that is the confidentiality, assures that private or confidential information is not made available or disclosed to unauthorized individual, right? So the contents which you have shared, it must be between only the sender and receiver. And the second part which we have discussed, that is the assure that information and program are changed only in a specified and authorized manner. It means no third person, no unauthorized person should be able to update or alter any kind of modification during the transmission of data over the network. That is the data integrity. And third, we have discussed the availability, that is the assure that systems work promptly and services is not denied to authorized users. Now the question is how to maintain this confidentiality, and we have said for that we need some mechanism. And what is that mechanism? That mechanism is cryptography. So before we go through in the detail of this cryptography, here we have some basic terminology, that is plain text, which is considered as original text which has to be transmitted over the network by the sender. Second one is this ciphertext. Ciphertext here we have considered as coded text. Coded text means encoded text. It means with the help of certain mechanism, with the help of certain algorithm, we have modified this original text to the encoded text, and this encoded text would be considered as ciphertext. And this cipher is considered an algorithm for transforming plain text to the ciphertext, right? And here this is the key, which is the sequence of bits which would be combined with this original message to make it this cipher. And that must be done only between the sender and receiver, because it is secret, just to use for the encoding and the decoding. And here the term which is encipher, or which we can say the encryption or decryption. It means when we are making the combination of the original message with the key sequence of bits and generating the ciphertext. So this is considered as encryption, or converting the plain text to the ciphertext. Similarly, at the receiver end, receiver will go through with the contents which is in the form of plain text. So it means it has to be decoded. So this recovering ciphertext from the plain text, that is the decipher, or we can say the decryption. So cryptography is basically the study of encryption principles of methods. So when we are talking about this cryptography, so crypto means hidden, graphy means writing. So hidden writing, which is the basic objective, which should not be easily understood by the hacker, that is the perspective of this cryptography. And this crypto analysis, that is the code breaking, it means that any unauthorized person who is trying to decode that particular encoded text, which is, we can say, the ciphertext, without knowing the key. So that is the code breaking. Normally hackers do that. Cryptology is the field of both cryptography and cryptanalysis. Now come to the main topic, that is cryptography. So when we have talked about this cryptography means hidden writing, it means that is the Greek word crypto, which is hidden. So how to hide this content which has been transmitted over the network. So here we are saying this cryptography is the study of secure communication techniques that allow only the sender and intending recipients of a message to view its contents. It means whatever contents you have transmitted over the network, it must be known between only the sender and receiver. Now here, when we are saying that we will apply the certain algorithms for the encoding and decoding. So definitely certain encryption operations are involved in that. So here we have the types of encryption operations which are used in the algorithm, that is the substitution and transposition. When we are talking about this substitution, that is the convert word letter to the another, that we'll discuss afterwards. Then the transposition, change position of letter in the text. So how to change the position? So instead of substituting, we will change the position. We will discuss with the example. Then we will apply the different type of keys in the cryptography. So here we will discuss the two types of keys, that is the single key or two key. When we are talking about the single key, it is considered as the private key cryptography. And when we are talking about the two keys, we will consider it as the public key cryptography. So the way in which plain text is processed, again we have the two ways, either the block or string. So what is the meaning of it? It is not possible to convert the entire code, entire text, which is to be transmitted over the network by applying the algorithm. So we have the number of bits which is to be converted in the encoded form. So for that, we have the two ways. Either the blockwise you are converting the plain text to the encoded text, or you are applying bit by bit, one bit at a time for the conversion process. So it depends on the algorithm. So now come to the concept of this substitution cipher. Suppose here we have the sequence of A to Z that is written in the sequence, and here we have the sequence that is QWERT to M, that is the sequence of keyboard. So how we will substitute the alphabet corresponding the keyboard sequence, that is the consideration of this substitution cipher. This is just one example over here. And here we have, suppose example, the gray fox has arrived. So how it is considering G? Here we have this G. This G has been substituted with U, corresponding U. And here we have this R. R has been substituted with K. And A has been substituted with Q. And Y has been substituted with N. So this gray has been converted to the UKQN. So now it is encrypted code. It is the encoded code. It is the ciphertext, which is not easily understood by the hacker. And Fox, and here this F has been substituted by Y. O has been, where is O? This O has been substituted with G, and this X has been substituted with B. So Fox has been substituted with YGB. Similarly, HAS, this is H is substituted with I, A with Q, and S with L. So has been encoded with IQL and arrived. A is Q, and there is R with KK, I, and here is I, where is this I with O, V, V with C, and here this E with T, and D. This is D with R. So this is the encoded form for this array. So this is the simple method just to substitute the alphabet with the corresponding sequence, and that is applied normally in the algorithm. The another strong way to convert the operations, that is transposition ciphers. And here we may have this row transposition cipher, we may have the column transposition cipher, and even we may have the row and column combined transposition cipher. And here we will consider the example of this row transposition cipher. So a little bit more complex to decode. So write letters of a message out in rows over a specified number of columns, then reorder the columns according to some key before reading of the rows. And this key has been predefined, and this key is 431256 7. And here we have this plain text in the form of rows and columns, that is in the form of matrix, like attack postponed until 2 a.m. And this X, Y, Z are just added as the to complete this matrix. So how we will convert this plain text to the ciphertext with the help of this row transposition. So the key 1, which will follow the all rows corresponding for this particular column. So for key 1, T, T, N, A, T, T, N, A, and here we have these two, APTM, APTM, then 3, TSUO, TSUO, then we have 4, that is AODW, AODW, COIM, COIM, then 6, KNTY, KNTY, then 7, PETZ, PETZ. So this is the way to convert with the help of this row transposition cipher. Now come to the concept of the type of cryptography. As we have discussed, we have two types of cryptography, symmetric cryptography and asymmetric cryptography. So when we are talking about this symmetric cryptography, as the name specifies, symmetric means same. So same key has been used for the encryption and decryption. So that's why we are saying over here that is conventional, private or single key. So this single key has been used for by the sender and receiver. Both are sharing the same sequence of bits for the combination with the plain text to generate the encoded text. So all classical algorithms are using the private key algorithms. So after the invention of this public key in the 1970s, nowadays we are preferring this public key cryptography, where we are using the two keys, one for encryption and another for decryption. So if we highlight this symmetric key cryptography, if you just observe this particular diagram, so here we have this plain text. This plain text that is, of course, again in the form of sequence of bits, that is zeros and ones input, and which is represented over here as X. Now this X sequence of bits, which is the plain text, has to be combined with this key. And this key K is again the sequence of it, which has to be combined this X by applying any encryption algorithm. And here it has applied this AES algorithm, that is the Advanced Encryption Standard. And here, after applying this algorithm, it has generated Y, which is considered as ciphertext, right? So this has been transmitted over the network. So instead of transmitting this X, now it is transmitting the Y over the network, which is in the form of encoded text and which cannot be easily understood by any unauthorized person. So at the receiver end, we are receiving in the form of plain text. But how? At the receiver end, it is decrypting this particular ciphertext by applying the same algorithm, but in the reverse order and reverse of the encryption algorithm. But here we are using the same bit combination, same key for the decipherment. So this again, after the decryption algorithm, we are receiving this X at the receiving end. So that is the concept behind this symmetric key cryptography, or we can say the private cryptography. Now, algorithm which normally has been applied for this symmetric key cryptography, that is the digital encryption standard. So here we have this DES algorithm, and here we have this 64-bit plain text. So as we have discussed that we have two types of operations which we can apply over the plain text. That is, the one is block, otherwise is bitwise, that is string. So here we have the consideration of this block of bits, or we can see the block of plain text, and this DES algorithm considers the 64-bit plain text as a one block to apply DES algorithm. So we have, for example, the 3 blocks, or we can say the n blocks according to the text. So block 1, block 2, block 3, or for each block, it is considering the 64-bit plain text, and for each block, it is applying the DES algorithm, and for each block, it is applying this 56-bit key as a bit combination. So once this bit combination has been applied, it will discard the 8 bits as a parity bit and consider only the 56 bits for this operation. And finally, we will get the 64-bit ciphertext for this block 1, 64-bit ciphertext for block 2, and the same way. So if we elaborate this DES algorithm, so we can consider over here the feastal structure of a DES algorithm. So what exactly this feastal structure of this DES? So what is this feastal structure, which considers the multiple rounds of processing of this plain text, and each round consisting of the substitution steps followed by the permutation steps. So as we have discussed the substitution, how it is substituting the alphabet from by the other. So if you look at this particular diagram, we have the 64-bit plain text, and here we have this initial permutation and fixed 16 rounds over here, and finally we have the final permutation. And here we have this 56-bit cipher key. And here we have the round key generator. And this round key generator is generating the 16 keys with the help of this key generator, that is 48-bit. And for each round, we are having the separate key K1, K2 to K16. So for total 16 rounds, it is applying the different permutation combination, and finally it is generating the 64-bit ciphertext. Now again, we have the triple DES. So what exactly this triple DES? So as the term specifies the triple key, it means we are using the 3 keys instead of single key. That is DES cipher here. This for K1, then K2, then K3. So first DES cipher, then you are applying the reverse cipher, then again we are applying with the help of K3, the DES cipher. So this is the encryption process, and we are receiving the 64-bit ciphertext over here. And in the reverse order, K3, K2, and K1, we are getting the plain text by applying this decryption process. So user first generate and distribute a 3DS key, which consists of 3 different DES, K1, K2, and K3. It means we are having the 3 into 56, that is the 168-bit over here, right? Now come to the another aspect, that is the public key cryptography. So what exactly this public key cryptography? So if you look at this particular diagram, here we are using the plain text plain text at the sender end and plain text at the receiver end. But here we are using the 2 keys. One is for the recipient public key and the recipient's private key. So for the encryption, you are using the recipient's public key. For the decryption, and the recipient is using the private key for its own, right? So suppose for consideration, we consider the example of you want to send the mail to your friends. So you are having the mail IDs of your friends, and with the help of the mail ID of your friends, which is considered as the public key, and you have transmitted over the network. Now at the receiver end, the receiver with the help of its password of that particular mail ID just decrypt and just go through with the plain text. So that is the consideration of public key cryptography. Now come to the part of applications of cryptography in real life. So what are the different applications? Normally, at present, we have discussed the various perspective of the cryptography, and here we are going through the applications of cryptography in real life, that is the encrypting devices, securing email communication, as you have gone through with that, authentication or the digital signatures, authentications, verifying and protecting, or we can say the preventing from the breach of the integrity. And the breach of, just to avoid the breach of integrity, we use the digital signatures. And normally you have gone through that encryption in the WhatsApp, and it is applied the securing a website. So these are the various applications of cryptography in real life. So with this, I would like to conclude the session. Today, we have gone through with the basic concepts of cryptography, where we have gone through with the various key perspective, various operations which are performed to convert the plain text to the ciphertext, and the two types of cryptography, that is the symmetric and asymmetric cryptography with the real life applications of cryptography. Thank you.